Hi everyone, welcome back to my YouTube channel. In today's video, we are going to understand a very important topic from the standpoint of economics, which is how to do optimization. Optimization का मतलब क्या होता है, and how do you figure out, if you have a function, how to find the maximum value, how to find the minimum value, or what are the different criterias that are there. So we'll understand all of that. So I understand, you guys have your exam tomorrow. So I would like to wish you all the very best for your exam. So yeah, quickly, let's get started. All right, so let's start talking about some basic things, and then we'll understand, graphically that how do we decide which function is the maximum, which function is the like which point is the maximum, which point is the minimum, or what could be a general procedure to figure out the maximum or minimum points if you are given a function. So let's do that. All right, so let's start with the basics first. So, let's say you have a function. We have a function, and when will we be able to call a particular point, a point which gives us maximum value, or when will we be able to say that, you have a point which is, giving you the minimum value. So when will we be able to say that? Okay. So let's say, you have a function. We have a function f. Okay, we have a function f, and we want to say that, okay, let's say there is a point function, there is a point c in the domain of this function. So this is the function which has a domain d. What is a domain? Set of all possible points that this function can take. Okay, so let's say I have a point c in the domain of this function. मैं कब बोल सकती हूँ कि पॉइंट सी जो है मुझे मैक्सिमम वैल्यू दे रहा है फंक्शन की? ठीक है, so C, which belongs to the domain, is a maximum point for the function f. आप कब कोई भी एक पॉइंट को मैक्सिमम पॉइंट बोल पाओगे? कि आपने इस फंक्शन की डोमेन में हर पॉइंट हर वैल्यू पुट करके फंक्शन में देख लिया, और पॉइंट सी जब आप पुट कर रहे हो तब फंक्शन की वैल्यू सबसे ज्यादा आ रही है, राइट? दैट इज बेसिकली व्हाट वुड बी द मीनिंग ऑफ द मैक्सिमम पॉइंट, that you put all the points in the domain and you figure out what is the function value, and the function value when you put c should be the maximum. Then only you'll be able to say that, okay, c is the maximum point of f. Okay, so when will we be able to say that? When, so if and only if, if you find function value if you find your function value at different points, okay, and if you compare it with what is your function value at c, okay, and when you see what is the relationship, then you see that, okay, when you put value c in the function, it should be the maximum, right? For all the possible points that are there, if you put x value there, your function value at c should be the maximum. Then only we can say that point c is the point of maximum, right? So that's what we can do. So whenever this relationship holds, so whenever, fc has the maximum value for all possible values of x in the domain, then we basically can say that, okay, point c is the point of maxima. Okay, so this should hold for all x which belongs to your domain. Okay, similarly, what if I want to say that, okay, whether a particular point is a minimum point for function f or not, then also the same thing should happen, that whatever function value takes at that point, it should be the lowest when you put all the possible points in your domain. F, whatever point that is, that should be the lowest value. So let's say, I want to call that, okay, I have a point D which belongs to domain. I can say that this is the minimum point for my function. It's a minimum point for my function f. When will I be able to say that? If and only if you find the function value at different points and you find the function value at D. So whatever your function value you are getting at point D, it should be the lowest value. right? It should be the least value, right? It should be the least value. It should basically be your lowest value. When you put all, for all, this is basically the symbol for all x which belongs to your domain. So this particular condition should be satisfied for all x's, right? Why are we putting equal to x value? Because there could be other points also जहां पे आपकी value same हो, जो point C या same point D पे मिल रही है, but there should be no value which is giving you a higher value. Okay, so this is basically the convention or the definitions that we follow. Okay, so since we know that C suppose is the maximum point. Okay, so whatever is this value FC, this is basically your maximum value. Okay, since we know, let's say, okay, D point is the minimum point. So whatever FD you are going to get, this is the minimum value of the function. Okay. So what are these, different values called? We call these values as optimal values. So these are called with different names like optimal values. You can also call it optimal point. Okay. You can also say that these are extreme points. Okay. You can also say that these are extreme values. So these are different names which are, quite common for your point of maxima or your point of minima. So these are all the different names by which you can see your problems being asked. Okay. So काफी अलग-अलग तरीके के नाम होते हैं, and these are some common names that are being used. Okay. All right. So there is one more definition that you need to understand. Okay. So, let's say my function f that I'm talking about, let's say this function is differentiable. Okay. So let's say this function f, let's say I have a function f and f is differentiable. Let's say it is differentiable in a particular interval. Okay. In a particular interval I, let's say. Okay. All right. So let's say my function is differentiable in a particular interval and I have a point x naught in this interval. Okay. And I have a point x naught in this interval I, and it should be in the interior of this interval only, because at the extremes of the interval, the function is not differentiable. So let's say I have a point x naught. Okay. I will call that x naught is stationary when, so x naught is a stationary point for the function f if a particular special condition is being satisfied, which is if you find differentiation of f function with respect to x and you try to find its value at x naught, you should get the value to be 0. Okay. So what is a stationary point? So this is basically the definition of a stationary point. So what is a stationary point? A stationary point is basically a point where your derivative value is 0. Okay. So what does having a derivative value 0 means? So whenever your derivative value is 0, that means जो भी आपका function है, if you draw a tangent there, the slope of that tangent should be 0, right? What does a slope of a tangent 0 means? That means whatever tangent that you draw, it is flat. Okay, so let me just draw a diagram. So let's say we have a diagram like this. So let's say we have a diagram like this. Okay. If, you have different points available, you have different points that are there. Okay. So let's say, at this point you draw the tangent, it'll be something like this. If at this point you draw a tangent, it'll be something like this, right? But let's say if you draw the tangent at this point, you see that, okay, this is something like this. So slope of this line, a line which is parallel to x, the slope of that line is nothing but 0, right? So that means this is a point. That means this is a point. Let's say this is the x naught point where the derivative is equal to 0. So derivative 0 meaning When you draw a tangent at that particular point, so tangent to the curve of the function at that particular point, you will get a value of 0. Okay. So that means tangent is parallel to the x-axis at stationary point. Okay. So stationary point means nothing but, your derivative value at that particular point is 0. That is the basic meaning of a stationary point. Okay. So, our basic goal is to understand when does a function take a maximum value, when does a function take a minimum value. So basically, we are very much interested in finding the extreme values, right? जो भी आपकी मैक्सिमा मिनिमा वैल्यूज होती है उनको हम लोग एक्सट्रीम पॉइंट्स बोलते हैं, ठीक है. So we are, very much eager to find what are the extreme values of a function. Okay. So graphically, let's try and see, what kind of different possibilities could be there for finding maxima and minima, or, where is a stationary point. So we want to understand all these things. So let's try and see a few, examples of how a function might look, and, how should we search for finding maximum or minimum values. Okay. All right. So we basically want to see how different diagrams look like, and what is the role of a stationary point in finding maxima or minima. Okay, that is our goal. Okay. Okay. So let me draw some diagrams and let me ask you different things. Okay. So let's say I have a diagram like this. Okay. I make a diagram like this. Okay. All right. And let's say this is defined from here to here. Okay. This is, let's say, B value, and this is, let's say, A value. This is x-axis and this is y-axis. Okay. All right. So first of all, let's say this function is defined from interval A to B. And if I ask you, how many stationary points do I have? How many stationary points do I have in this particular function? So what is a stationary point? Stationary point is a point where your derivative value is 0. What is a derivative value 0 meaning? When you draw a tangent, it should be parallel to your x-axis. Okay, that is what it means. So how many points do I see which are parallel to the x-axis in this particular diagram? So one that I see is, so one is here, right? This is parallel to x-axis. And one I see that it is here. Okay, this is also parallel to the x-axis. So let's say this is point x1. And let's say this is point x2. Okay. These two are stationary points. So this particular diagram has two stationary points. Okay. And can you tell me, like, what is the maximum value of this function in this particular interval? कि ये जो function है ये अपनी maximum value कहाँ पे ले रहा है? I can see that, okay, यहाँ पे जो है, if I go here, at this point, my function is taking a maximum value. And I see that at this point, my function is taking minimum value, right? So at x1, your function is taking minimum value. And at x2, your function is taking a maximum value. Why is this useful? We'll come to know. Just register this in your mind for now, okay? Let's see, we have a different situation coming up. Let's see a different situation. And let me draw another diagram. Okay, so let's say I have a diagram which looks something like this. Okay. All right. This is, let's say, point A. This is, let's say, point B. Okay. And let's say this is point C. Okay. And you have to first tell me how many stationary points are there in this particular graph. So do you see any stationary point in this particular graph? So stationary points would mean any point where the derivative is parallel to the x-axis. Okay. So, I don't see anywhere it being parallel to the x-axis, right? At this point, this is a corner point. There is a very sharp edge here. So the derivative doesn't exist at this point, right? Because you can have multiple tangents over here. Okay. So at point C, your function is not the derivative of this function doesn't exist. And basically, I don't see any point wherein the derivative is equals to 0. So I don't see any point being a stationary point here. Okay, so we don't see any point being a stationary point here. So there are no stationary points here. Okay. But can you guys tell me, okay, what is the maximum value and what is the minimum value here? So, like there is one value here, there is one value here, and then there is one value here. So what is the maximum value? When x value is b, your function is taking a maximum value, and when function value is c, your function is taking a minimum value. So just remember this, that okay, at point C, we had a minimum value, and at point B, we had a maximum value. Okay. And there are no stationary points in this particular case. Okay. All right. Let's see another situation. Let's see another diagram. Let's study that. So let's say we have a situation like this. Let's say I have a situation like this. Let's say I have a situation like this. Okay. So, if we ask how many stationary points are there, and let's say your function is defined in this particular interval a to b, or maybe you can say that, okay, let's say that's not the case, and your function is just taking values like beyond this and beyond this. Okay. All right. So first of all, let's answer how many stationary point this particular curve has. So there is one stationary point here, one stationary point here, and one stationary point here, right? Because here also, at one point the slope is 0. Okay. So we have x1, x2, and x3. So these are the 3 stationary points that we have. Okay. But can you tell me, like, what is the maximum value here and what is the minimum value here, right? So, okay. I can see that this function value is going down and down. So I don't know what is the minimum value here. And I can see that this function value is going up and up here. So I also don't know what is the maximum value here. But I can see that, okay, neither this is the maximum value, nor this is the minimum value, nor this is the maximum value. Nothing like that is the case here, right? But suppose, I just say that, okay, let's say my function is defined between these lines. So like this is x equals to a, and I say that, okay, my function is defined here. This is b. If I ask you this question, like what is the maximum value and minimum value now, then what can you say? Then you can say that, okay, like, okay, I can see that, okay, this is the starting point. It goes like this and this and this. The maximum value is obviously at x equals to b, and the minimum value it has x equals to a. Okay. And this particular function has 3 stationary points. Okay. So these are different situations that we have seen. Okay. All right. Okay, so we will be using all these ideas that we have understood in a moment. Okay, so before that, let's say I want to say, I want to talk about when does a function has a maximum value or a minimum value. So I want to state a result regarding that. Okay, so suppose you have a function f. Suppose fx is differentiable. Suppose you have a function which is differentiable in an interval. Okay. It's differentiable on an interval I. So you will not see a situation like this. So if this A to B is my interval, so you'll not see a situation like this. So there are no sharp edges basically. So this is not the interval where your function is differentiable, because there is a sharp edge. So whatever interval that we are talking about, your function is differentiable in that entire interval. So there are no corner points, no edges. Okay. So if that is the case, okay, and suppose that, fx, which is your function, it has only one stationary point. Okay. Suppose your function only has one stationary point. So if your function has only one stationary point and it is differentiable, so, it might look something like this. Like, it might look something like this, that, okay, this is the interval, let's say a to b. Okay. And your function is differentiable in this entire interval. There is no corner. Okay. And, there is one point where the tangent is parallel to the x-axis. Okay. So we are talking about a function which has, all these properties. So something like this. Or you can have a function like this. Okay. So this is differentiable and there is only one point where your function has a stationary point. Okay. And let's say this is the a value and this is the b value. Okay. So if we are talking about such functions which are differentiable in an interval and there is only one stationary point that the function has, then, and let's say that point is x equals to c. So let's say this is the point c and this is the point c. Okay. Let's say we are talking about such functions. Then what can I say? Then we can say that if your f prime x is greater than equal to 0 for x less than equal to c. Okay. And if your f single prime, derivative of f is less than equal to 0 for x greater than equal to c. So that means, what are we saying? That for whatever point that you have, so, whatever point that you have, let's say this is the point that we have. This is my point c. If on the left of c, your derivative is greater than or equal to 0. Okay. And if to the right of this function, if to the right of this point, your derivative is less than equal to 0. If that is the case, then we will be saying something. But, before doing that, let's understand this. So let's see this case. Okay. This is my point C. Okay. To the left of point C, I have to check like what is the slope of my tangent. Is it positive or is it negative? So this case is saying if to the left of point C, your slope is positive or equal to 0. So to the left of this point, I can see that my slope is positive, 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 positive. And at this point, it is 0. So to the left of C, if your slope is positive, and I can see that positive or either equal to 0. So I can see that, okay, to the left of this condition is being satisfied, right? And if to the right of this point C, your slope is negative or, derivative of x is less than or equal to 0. So here I can see that, okay, here it is 0 and then it's negative, negative, negative. This tangent is downwards. That means the slope is negative. So then they are saying, can you see what kind of thing are we going to say? If you see point C is the point of maxima. Okay. So if these conditions are satisfied, your function is differentiable. It has only one stationary point. To the left of point C, the derivative is either equal to 0 or greater than 0. If your derivative to the right is either less than equal to 0, right? Then what can I say? Then I can say that x equals to c is a maximum point for your function, f. Okay. And we see this also like this happening here, that point C is actually the point of maxima, right? There's nothing beyond this particular value, right? And similarly, if you see that, okay, to the point which is to the left of C, if your slope is negative or equal to 0, and to the right of it, if it's your slope is negative, positive or equal to 0, then what kind of point is C going to be? If you see this diagram, what kind of point is C? C is the minima point, right? C is the point of minima. Okay. So, similar thing I can say that if f prime x is less than equal to 0 for x to the left of C, and your f prime x is greater than or equal to 0 for x which is greater than equal to c. So basically to the right of point x, then what can I say? Then I can say that x equals to c is actually a minimum point for your function f. Right? So this was a minimum point for your function f, right? So, whenever you want to remember these things, just remember or keep this diagram in your mind and keep this diagram in your mind. Okay. So, if you have your function differentiable and there is only one stationary point, and either this condition is satisfied, then it's a maxima point. If this condition is satisfied, then it's a point of minima. Okay. But you see, this was a very, very special case. Like there is only one stationary point, it's differentiable everywhere, and all of these beautiful and nice, well behaved, all the properties that are there, right? But most of the times, jo bhi aap functions dekhoge, they are not going to have all these nice properties, right? So like in those cases, how do we decide like what is the maximum value and what is the minimum value? How should we go about it, right? What should we do? Okay. So like the main question that I have is how to decide like what to do if we want to find the extreme points in general. Okay. What if I want to find the extreme points in general? And what if my function is not so good that there is only one stationary point and all those nice properties are being satisfied? Then what do I do? Then, so let's now go back to the diagrams that we've studied. So like what is the general procedure to find the maximum or minimum value? Okay, let's see. So I am clear with my objective that I want to know how to find the extreme points in general. Okay. All right. Okay. So, let's see this diagram. If we see this diagram, in this case, this was my minimum value and this was my maximum value, right? So what kind of points were my maxima or minima? So this was a stationary point and this was a stationary point. So in this first case, what kind of points became my maxima or minima? These points were stationary points, right? Okay. All right. That is the first thing. Okay. Let's understand the second diagram. Okay. If you talk about the minimum point, what was the minimum point in this particular, interval? So I see that C was my minima point. What is the property of C? C, at point C, your derivative did not exist, right? So at point C, derivative did not exist. Okay. Now, if we see this point and this point, okay. All right. So minimum point, we saw that, okay, C was the point where we had the minimum value. And at this point, the derivative did not exist. Now, if I talk about what was the maximum value, I see that, okay, point B had the maximum value. And what is the property of point B? Point B is an end point in this interval, right? It's a border point. If my interval is A to B, point B was a border point, right? So point B was a end point, or you can say border value. Okay. So in the first case, my stationary points became my maxima minima. In the second case, where the derivative did not exist, that became my minima, and maxima became the end points of the interval, right? In this case, what happened? In this case, if we don't put this interval here, I see that there is no maxima or no minima, right? And if I put my intervals here, okay, if I put my intervals at A and B, then what do I see? I see that, okay, neither this was my maximum value or minimum value, neither this was my maximum or minimum value, neither this was my maximum or minimum value, right? If you put borders here, like this is your interval, let's say, then A is your minimum value. At point A, you have your minimum value, and at point B, you have your maximum value, right? So, in this case, you say that, okay, stationary points se to stationary maximum minima ho gaye, but here also we had stationary points, three stationary points. but none of them was the maximum or minimum value. It actually were my border points which became my maximum or minimum value, right? So in this case, we see that jo aapke border points hai, the boundary points, they became the maximum or minimum, right? So this point A is minima, and it was a border point, right? Border point. And point B was my maxima, and it was also a border point. Okay. So after, doing a post-mortem of all these diagrams, there is some conclusion that we can make. And what is that? Let's see. So whenever I am, I was studying where is my maxima or where is my minima, then there are two things, two, three things that I could gather. First is, let's say that C is let's say I have a function and C is the maximum value of that function. Okay. So C is basically a point where your function is taking maximum value. Okay. Suppose. So here we are trying to establish some steps or, some philosophy or guidelines to find maximum or minima. So let's say, I have a point C at which my function is taking maximum value. Okay. And my function is defined in an interval. Okay. So there is an interval in which my function is defined. And in that interval, there is a point C, which is basically, the point of maxima. Okay. All right. So your function, like your point C could have either of the two properties. Let's say if your interval is A comma B. Okay. Let's say this is your interval. So this point C that we are talking about, it could either be a border point, right? It could either be A or B, because these 2 points are the border points or the boundary points, right? So C is either a end point, right? That is the first thing, right? Or what kind of properties C might have? If it's not an end point, it is something which is interior of this interval. C is an interior point, right? तो या तो आपका जो फंक्शन है वो एंड पॉइंट हो सकता है, या तो आपका जो पॉइंट सी है वो एंड पॉइंट होगा, या तो ए या तो बी, या फिर इट विल बी एन इंटीरियर पॉइंट, समथिंग विच इज इन द मिडल ऑफ द इंटरवल, राइट? Like somewhere in the middle of the interval, not the edges. Okay. So these are the two things that your function, your point C might have, right? So if it is either the end point or it is an interior point, right? And we see if something is a maxima or minima in the interior. So you see, this was the end point. And in this case, your function had a maxima or minima at the interior points. So this value x1 or x2, they turned out to be stationary points, right? And, in this case, since, this border value was maxima, fine. But what was the minima? Point C. And what was the property of point C? That your function did not have a derivative at point C. Okay. In this third case, your maxima and minima were actually point A and B. And, point C was not in the middle. So wherever you see point C being an interior point, it is either a stationary point or, the derivative does not exist at point C. These are the two properties that can happen, right? So either C is a stationary point, and stationary point meaning what? That f prime C equals to 0, or, f prime does not exist at point C. Okay. It could very well happen like this is the case. Okay. And, you see, even if you have a point C where the derivative is 0, that doesn't mean like, it has to be the point where you see your maxima or minima, right? Because, in this case, we saw I had three different points which were the stationary point, but they were not the maxima or minima points, right? But wherever you see this being a maximum value, if there is any maximum value in the interior and your function is, defined here, your function derivative is defined here, it should be actually a stationary point, right? So we see that, being f prime c being 0 is a necessary condition. Necessary condition to be an optima in the interior points. If your function is differentiable everywhere, if it's not differentiable, then, this is not even the necessary condition. But if your function is defined and its derivative exists at every single point in the interior, then f prime c being equal to 0 is actually a necessary condition for being optima. Like, it has to be a stationary point. But if your function is not differentiable, then, you can still have a point where the function did not exist, the derivative did not exist, and you still have either a maxima or a minima value, right? But wherever you have a maximum value in the interior and your function is differentiable, your derivative should be 0 at that particular point. So this is like a necessary condition. This is a necessary condition to have an optima in the interior, but it's not a sufficient condition. Okay. It's not sufficient. It is not a sufficient condition, right? Because as an example, you see, I give you a function like this, right? I can give you a function like this. Okay. And okay, I have to make it a little better. So let's say I have a function like this. Okay. So this is basically the diagram of y equals to x cube. Let's say it's defined from 1 to -1. Then, if you see in the interior, excluding the outside points, like the boundary points, if you exclude them, you see that here your function f prime x is 3x square, which is nothing but 0 if x value is 0. So here the derivative value is 0, but still your function is not taking any maxima or minimum value here, right? But basically this f prime c being 0 is a necessary condition to have any optima in the interior of your interval. Okay. It is not sufficient. Right? So what did we see? We see that, any point which is either becoming a maxima or a minima, it is either a stationary point, or it is a border point, or it is a point where your function derivative does not exist, right? So jo bhi aapke candidates hain, so it's like, you can assume all these numbers are people, and these people are fighting an election. So ye sare candidates ho gaye for, running the race. So who is the candidate to be a maxima winner or a minima winner? What are all the properties of these candidates? Either those candidates are stationary points, or these are points where the differentiation does not exist, or they are basically your, so I said stationary point or border points, or the points where your function is not differentiable, right? So all the candidates who are running, all the candidates which can give you, all the candidates basically which can give you a maximum or a minimum, right? Follow either, like, they fall in any of these three categories. So first category is endpoints of the interval, maxima minima in an interval. So if there is any function which is defined in an interval, and if you are looking to find the maxima or minima, all the candidates who are fighting to be the maxima or minima follow either of these like three categories. So either they are endpoints, right? So endpoints of the interval, right? So either they are endpoints of the interval. What is the second criteria? Either they are, the stationary points, right? So they are stationary points. So stationary point basically mean the interior points where f prime x equals to 0, right? So either वो इस कैटेगरी में फॉल करते हैं, या फिर जो तीसरी कैटेगरी है वो क्या है, वो सारे पॉइंट्स जहां पे f प्राइम does not exist. So these are basically three categories of candidates who can fight the race to be a maxima or a minima, right? But in economics, or in the general discussions that we have, we usually talk about the candidates or the functions which are differentiable. So we will not talk about this in our discussion. Okay? So let's try to restrict our discussion to the functions which are differentiable in any particular interval, right? So I see that जो भी candidate मेरा maximum और minimum बन सकता है, या तो वो end point होगा, boundary point होगा, या तो वो एक stationary point होगा, या तो फिर वहां पे डेरिवेटिव एग्जिस्ट नहीं करेगा. ये तीन ही कैटेगरीज के कैंडिडेट्स जो हैं वो फाइट कर सकते हैं टू बी अ मैक्सिमा और अ मिनिमा, राइट? So because we are not generally talking about functions which are where the derivative does not exist, तो आप क्या करो, either we can skip this, or even if you get a case wherein you have a function which is not differentiable at any particular interval, then what you can pick is just pick all the candidates. So find all the candidates which are endpoint, find all the candidates where your function is stationary, find all the candidates where your function is not differentiable. So now you have all the candidates. So let's say you have 10 candidates. So now that you have 10 candidates, can you decide which is the maximum value and which is the minimum value? How can you do that? So let's say if I have 10 candidates, so basically I have 10 x values, which are either of these categories. Then I can just put those 10 values in my function and decide which is the maximum and which is the minima. So this is far more an easier problem to deal with, right? Rather than doing the entire function, I can just look at how these 10 candidates are behaving and decide which is the maxima and which is the minima. And yehi hamara general procedure. And this is exactly how our general procedure is going to be. Okay. So let me just formalize this and say that, if you want to find maxima or minima, so if you want to find maxima or minima value of a differentiable function, because we usually restrict ourselves to differentiable functions, of a differentiable function. So if you want to find the maximum or minimum value of a differentiable function f, which is defined on a closed and a bounded interval. So closed and bounded interval would mean like your endpoints of the interval are also a part of that domain, and it's a bounded interval. So it can't be like, closed interval 0 to infinite. Infinite is not a bound. Okay. So you have something like this. So if your function is differentiable in this particular interval, okay, I mean, differentiable will be on the open interval, but if your function is defined in this entire closed and bounded interval, and if your goal is to find the maxima and minima, then how do you go about it? So now decide what to do. So first of all, what is the first step? First step is to find all the stationary points, because mujhe pata hai all the maxima minima will, be either this or this, because we are talking about differentiable function. So this category is not included. So I know maxima minima ya to endpoint hoga ya to stationary point hoga. Either it will be an endpoint or it will be a stationary point. So first find what all stationary points do you have in this open interval, right? So find all the stationary points. Stationary point means all those points where your derivative is 0, right? all the stationary points of f in this open interval a to b. Okay. Second thing, this is the first thing. Okay. So now that you have your stationary points, find what is your function value at these stationary points, right? Find function value at these stationary points. So find what is your function value at these stationary points. So find stationary point, find the function value at stationary point also. But we know the second category of maxima, minima are usually the endpoints, right? So I will also find my function value at the endpoints, right? So मुझे मेरे function की value मिल गई stationary points पे भी और मेरे end points पे भी, right? The third step will be find the function value at the endpoints, right? So आपने function value endpoints पे भी निकाल ली, like A और B पे, and आपने stationary points पे भी function value निकाल ली. Now it's very, very simple. Now just choose, like out of all these function values, which is the which point, which x value is giving you the maximum function value, and which which x value is giving you the minimum value of the function. And that is basically your like goal has come to an end. You have picked up a maxima and you have picked up a minima, right? So find the largest value of f and finally find the smallest value of f. Out of all the values that you have calculated. ओके सो दैट इज द प्रोसीजर. आप अपने स्टेशनरी पॉइंट्स निकालो, एंड पॉइंट्स पे फंक्शन वैल्यू निकालो, हर जगह फंक्शन वैल्यू निकाल के देखो ये सारे पॉइंट्स के बीच में, एंड देन डिसाइड विच इज गिविंग यू द मैक्सिमम वैल्यू एंड विच इज गिविंग यू द मिनिमम वैल्यू. सो यू हैव योर मैक्सिमम पॉइंट एंड मैक्सिमम वैल्यू ऑल्सो, you have your minimum point and your minimum value also, right? Some people might be having this question in their head, is it really necessary for a maxima to exist? Is it really necessary for a minima to exist? क्या जरूरी है maxima क्या पता exist ना ही करे? We've seen examples. So let's say if I give you function fx equals to x and the domain is all real numbers. Okay. Can you tell me what is the maximum value of this? You can't. Can you tell me what is the minimum value of this? You can't, right? So what makes us think that, okay, there is a maximum value and there is a minimum value that will exist when we find it like this? So can you think of why we might be able to say that? So do you guys remember what is the extreme value theorem? So I've done a video on extreme value theorem. Extreme value theorem क्या बोलती है? If you have a closed and bounded interval, okay, and if you have a continuous function, then it will take a maximum value also and it will take a minimum value also. So we are applying that theorem to, not worry कि हमारा maxima exist करता है या नहीं. It exists because of extreme value theorem, right? So extreme value theorem says if your function is, continuous, okay, in a closed and a bounded interval, then it will definitely have a maxima or minima. Here we are talking about a differentiable function in the interval a to b. A differentiable function is continuous also. So hence using extreme value theorem, we can say that हाँ बिल्कुल maxima और minima दोनों ही exist करते हैं. इसीलिए हम लोग ये सारा process को बहुत ही smoothly run कर पाएंगे. ठीक है? So this is the entire procedure that we follow to find maxima or minima. So, okay, guys, let's do an example here and try to figure out like what is the maximum value and minimum value. Okay. So let's say somebody asks you, find the maximum and minimum. Okay. Of what function? Of function fx equals to 4x square minus 40x plus 80. Somebody says ये function है, इसकी maximum value बता दो और इसकी minimum value बता दो. Give us the minimum and maximum value of this function. And when we are talking about x, which belongs to the interval 0 to 8. Okay. So we have defined that, okay, in this interval 0 to 8, can you tell us like what is the maximum and minimum value of your function, which is given by this particular expression. Okay. So x 0 to 8, it's a closed and bounded interval, right? Okay. This function is a polynomial function. Polynomial functions are differentiable everywhere, right? So it is differentiable also. So my function is differentiable also. My function is defined on a closed and bounded interval also. So those properties are nice, right? So now for me to be able to find the, maxima or minima, what are the steps that I have to follow? So the first step is find all the stationary points in this interval. So first I'll find what are the stationary points in this interval. So what is a stationary point? So for finding stationary points, what do I have to do? I have to find what all points f prime x is 0. So find f prime x first of all. So what is f prime x here? If you do f prime x here, what do you get? This is 8x minus 40. And I have to find for what value of x, f prime x is 0. So if I put it equal to 0, then I get what? X should be 5. So x equals to 5 is a stationary point, okay? And if in a question they ask you find the stationary point, just differentiate your function and find for what all x values is your derivative taking value 0, okay? That is the first step. So they ask us to find all the stationary points. So there is only one stationary point here. Okay, that's fine. Second, find the function value at these stationary points. So what is the value of this function at the stationary point 5? So what is f5? So if I do f5, what do I get? 4 into 5 square, which is 25, minus 40 into 5 plus 80, right? So 25 into 4 is 100, minus 40 into 5 is 200, plus 80. So this is basically minus 100 plus 80, which is minus 20. So my function value at 5 is minus 20. Okay, that is the first thing. All right. So that is the first thing. Now, what is the next step? So हमने stationary point निकाल लिया, stationary point पे function की value निकाल ली. अब function value निकालो end points पे. So end points क्या है? 0 and 8. So find the function value at 0, which is, just put 0 here and 0 here. You will get 80, right? And find the function value at 8. So you get what? 4 into 8 square. 8 into 8 is 64 minus 40 into 8 plus 80. So what do you get? So 4, 4, 16, 1, 6, 24, 1, 25. Yeah. 256. I hope I'm not wrong. Yeah, I think it's fine. Okay. And then 320 plus 80, right? So what do we have here? Okay, so if we do the subtraction here, I get, so this is nothing but if I subtract, so this is 20 and 44 and 20. So basically 64. So I get minus 64, right? Minus 64. Yeah, I get minus 64 and plus 80. So what is F8 basically? This is, 6 and 1, which is 16, right? So I get a plus 16 for 8, okay? So F8 is 16, F0 is 80, F5 is minus 20, okay? So now if you have to find the maxima and minima, out of these three values, just pick which is the largest and just pick which is the lowest. So what is the largest value out of these three? Largest value is this, okay? And what is the smallest value? Smallest value seems to be this, right? So x equals to 5 is a minimum point, okay? It's a minimum point. And minimum value is minus 20 is your minimum value, okay? What is your maximum value? What is your maximum point? So x equals to 0 is a maximum point, right? It is giving the maximum value. It's a maximum point, right? And then what is the maximum value? What is your function value at x equals to 0? It is 80. So your 80 is the maximum value. Okay. So that is how you can figure out like what is your maximum value and minimum value. Okay. So these are all the steps that you have to follow. So first of all, you have to check whether your function is differentiable or is this interval closed and bounded. If it is, then just follow this procedure and it will seamlessly give you what is the maximum value and what is the minimum value. Okay. All right. I think, guys, this is it for this particular video. And I think we are yet to do some more topics, which is, finding like related to concave function, convex function. So I'll soon be uploading one more video on that particular topic. So till then, keep studying. And I hope this video was helpful for you. If you enjoyed watching it and if you're able to understand, please like this video, subscribe to my channel, and share it with your friends, and have a nice day. Thank you so much.